So, hello everyone. It's great to be here today in the 20th anniversary of PyTexas, my first day as a speaker in a big conference. So, thank you. I am Silvia Mielniczuk. I am a mom. I am a trail runner, so really I appreciated the presentation by Adam, and probably I will use that application he built for my next marathon. I am also a Michigan alum, so go blue. And today I will tell you about my day job. In my day job, I work with companies that are making sense of their machine data. So I work with companies that are collecting and analyzing data for their observability and security use cases. And lately, what I've seen is that teams are integrating AI systems to their workflows, and also dealing with new challenges regarding the adoption of AI in many other areas of their own companies. So that's the motivation for this talk. The idea is that the moment we connect a model to a system or internal tool, we are not longer generating text, we are generating actions that might have real impactful consequences. So we have the model context protocol as a way to structure how the models interact with those tools. And today I'm going to walk through how we can use MCP to design with Python interfaces that are safer, more predictable, and easier to understand. So I will go ahead and do a quick presentation about the open standard of the Model Context Protocol. It defines a common language for how AI systems interact with tools, data, and external systems and services. Without MCP, we have the typical problem, M models, M tools, and N times M custom integrations. With MCP, we can define the interaction once, and everything can plug into it. So for Pythonistas, it's like having a universal abstract-based class that works for every tool that you will ever write. The architecture that the Model Context Protocol follows is client-server. So we have the host, where the LLM model runs and reasoning happens. We have the MCP client, that is the one that manages the sessions and the transport, turning intent into a structured request. And then we have the MCP server that technically, a raw server, is a stateful message processor, and it sits on the other side of the transport and is listening for JSON, and it's routing requests to Python functions, but it can be much more. It can be our control and governance plane. So it will expose capabilities, validate requests, and enforce policies. So inside the server, we have 3 key primitives. And these primitives allows the server to be declarative. We have tools that actually do the work. They, for example, query a database. We have the resources that can include data and context, such as a schema or a file. And then we have the prompts that provide templates that ensure consistent and reusable interaction. In our example of the database server, we can expose a resource that could be a schema, a prompt that has a few short examples of valid SQL for a specific dialect, and then the tool that actually performs the query. So this allows the LLM to navigate the system autonomously, discovering capabilities, and dynamically working those without relying in hard-coded instructions. All of this makes the control and governance plane of our MCP server. But also I like to think about the MCP server as a design layer, because it enforces a Pythonic separation of concerns. The model reason, the server controls, the tools execute, and the systems, well, they store the data, things like that. This creates a critical boundary that allows us to have a model that suggests actions but no longer directly execute the actions or are tied to execution. Because every request follows through the server, we have a centralized place to validate inputs, enforce policy, and crucially log everything. So it turns tool use from implicit behavior into a control observable system. That doesn't come free. So the server gives us a space to build this isolation layer, but what happens is that when the model is working autonomously and has the power to reason, there are other threat patterns that are coming up. And now our system can and may be manipulated. So specifically, we have to design for 3 foundational risks that are unique to agentic workflow. We have this malicious MCP server that cannot be trusted. It doesn't have to be malicious, but being a third-party server that we don't have control, we shouldn't trust it. And it could create a supply chain risk. So you can be access a tool in a server that says that is reading configs, but actually is hunting for APIs. And so you might be in trouble. And for sure, you will be if you trust it like you trust the pip packages. We also might have a malicious or misguided agent. And in this situation, we may have a problem if, for example, a simple tool like delete outdated logs is used too aggressively for a model that goes off rails. And the last pattern is the confused deputy. In this situation, we might have a tool that has high privileges to do some things in our systems, that is strict to perform actions where the user shouldn't be allowed to do. So, for example, exposing API keys. At this moment, I imagine you might be thinking, well, what about the access control? It's everywhere, and it's a natural question. Identity, authentication, authorization are part of every enterprise-grade application, and they are a must-have. And we already use roles and permissions in our different applications to control what the user can and cannot do. But as this comic shows, we are not 100% secure if we have the right access under control. In the agentic world, agents are acting on users' behalf on multiple different systems. And even if the permissions are technically right, that doesn't mean that a specific action the models might be suggesting makes sense or are a good idea. So the problem is shifting from who you are to what's going on right now. That's why in this presentation I am focusing on the control of the point of execution. MCP gives us a window to evaluate each action before it happens or while it's happening, and it helps us to ensure that the VIP pass to a system doesn't turn into a blank check to an agent for do whatever they want. So as I was creating a toy model, a toy system to present today and to demonstrate all the things that I am thinking about MCP as a control and design layer, I decided to do one with raw MCP directly and the other one of the servers in the system with fast MCP. Because I really wanted to show what it is happening under the hood. As the framework, FastMCP is abstracting lots of things. And here is the comparison side by side. In the first column, we have FastMCP. It's Pythonic, it's convenient, it abstracts a lot of the complexity of the JSON plumbing that is shown in the raw protocol column. And it makes tool creation fast. But the entire point is that plumbing is not policy. So the abstraction simplifies the setup, but it doesn't cover control and observability. And having the ability to make a server so quickly, to create that server so quickly, sometimes might mislead us to oversee the three points that I have been talking about so far: the separation of concerns, the unique agentic workflow threats, and the challenges for access and control. That's why I included that last column that is your superpower, and that's governance policy. We use the MCP server as a standardized way to connect things, but that's not the only reason. Another good reason to do that is that it gives us predictability. So we can use Python to define predictable interfaces, gain visibility, build isolated environments, and enforce boundaries. Fast MCP gives us fast implementation, but you provide the governance and the application will be secure. So next, I'm going to show you how this superpower is layered into the architecture of the toy system I created. Wait a second. Thank you. So this is the architecture of my small toy system. We have one agent that is orchestrating two servers to do some activities. So if you look at the diagram, you will see that I am moving from the plumbing to the policy of the system, of the actual system. On the top layer, I have an agent that is running locally. It's running in Llama 3, on Llama. And the model is the one that is handling the reasoning, but I wrapped it in predictable interfaces. We sanitize inputs, we validate outputs against the public schema that is advertised by the servers. And if the request doesn't match that schema, it never reaches the next layer. So it keeps our backend clean and forces that the agents fix out their own problems before it could cause any trouble in our system. The second layer is the governance boundary, and this is where we gain total visibility because all communication is forced through the standard I/O transport pipe, and I am using a local server. That is why I'm using standard I/O, but it could be a third-party server. We have a single control point to intercept and log everything. We treat every message as untrusted until it passes this gate. And finally, we have the third layer, which is the execution. And that is where things happen. The model processes the action based on the schema it sees, but the server has the ability to enforce private constraints that the model cannot talk its way around. The server performs its own validation, checks execution limits, runs policy checks, and even the model is proposing, the server is the one that is deciding what's going to happen or not. So I decided to create this architecture full locally because of two things. One is that I wanted to focus specifically on the execution control. And the second one is that I'm terrified that if I use internet for the demo, it wouldn't work. So that's why the why for all the things. So the moment arrived. You can see that all the code for this is in this repo. You can access it through there. And let's hope this works. I did everything right? I couldn't dream a worse nightmare than this. But I'm just kidding. I'm going to go to the Streamlight app, and we are going to see my demo, hopefully, right? Well, I will look at this screen, I think. So what we have here is this very simple interface. I have a way to interact with the system. I'm going to tell the system that I want to enrich some customer data. The agent is going to go to a untrusted MCP server somewhere and look for data to enrich my database. Then the agent will have to interact with my trusted MCP, the one that is protecting or having behind my database, and it's going to try to update the database or send an email to some person, because those are the two tools that he has available. So the idea is to run this in 3 different use cases, and we are going to see the full trace behind the scene. Let's hope it works. I will reset the logs. Great, it's working. So we will start with our happy path. I am running the scenario. Run, please. Okay, so what's going on here? The agent saw which is the customer that I want, and it's telling me that it needs a human approval, because the agent said, well, I found some data, it's relevant, so I would like to update the database. That's something that it cannot do by itself. It has to have a human in the loop, so I approve it. And now we can see the flow of all the gates that I was talking about. This happened, this in red, it's not a problem, it's just showing that the interactions between the agent and the external untrusted server. Then we have the agent boundary. So the agent ran a sanitizer. This sanitizer didn't found any flag, anything that seems a problem to the agent. So it went ahead and make a decision. And the decision was to update the customer strategy in my database. It summarized the decision, and here it's logging my approval. And then we went to the execution layer, and this is happening in our trusted MCP server. The server receives the request. It doesn't break or conflict with any of the policies we have there, so it updated successfully the database. And this is our happy path. We can see the protocol loggings of what's happened at any time, the tool calls and the responses, and also what happened at the agent side. I'm going to reset again, and now we are going to see a case in which we have this potential threat regarding what's coming from in the data from the strange MCP servers. Again, the agent goes, fetch the data, and this time it is flagging the risk inside the content of the data that he's bringing. He discovers that something might be an instruction-like text. So it asks the human approval, and I am being very lazy. I really don't care. I will approve this even though it flags a risk. Again, we see the interaction with the external server. We see that the agent is deciding that there is a risk, and I recommend next play. He demonstrates what is the text that he sanitized and the recommendation. Next, we do the decisions. They're sanitizing information. He decides that related to this in a different term. And in this scenario, what we're going to see is that our agent, when found some data and criticized, that it's a good idea to send an email. Again, the emails are sensitive, so we are using the human in the loop. I approve it. We can see interaction. The agent doesn't flag anything.
and the agent decides to send the email, show that I approve, and then when we want to rinse the server, we can see that the server executes the reaction. However, send the information to a local internal domain because the server that I designed didn't allow external emails.
So it created this. It went through with the strategy that the LLM proposed, but it decided to send it to a local email following its own policy. And that's it. That's our demo. It looks like we are safe. Okay, we have control under everything. But in fact, we are just starting. Let's see what's next in our agentic world and how MCP can help there. So what we saw today was a typical simple orchestration case in which one agent is working with two external MCP servers. And right now, we just have one agent. It accesses a tool, interacts, the other agent, the same agent interacts with another tool, and the servers execute. However, what we are seeing is that we are moving to a place in which automation is picking up fast, and we have servers that are, because of their capability of composability, they are working as client to other servers. So some agent can ask for some resources, and an agent can ask a server, and that server can behave as a client to a different server, and that one to a different server. And when we realized we don't know what's going on or what's happening, two loops ahead, two hops ahead. And still, being able to have a control and a very thoughtful policy can help us to have governance over those type of systems. At the same time, we are seeing a lot of different patterns like agent to agent that are delegating their tasks to other agents, creating a delegation of trust. And in that sense, how do I manage the fact that I trust this agent, this server, and how do I transfer that trust to the agent that is being called by its peer? So that's one of the situations of the challenges in this composable world. And the other one is how we avoid to get in a loop of infinite costly logic of interactions among agents. So as we get into there, the reason of my talk was to make everyone aware that the fact of focusing on the separation of concerns, the new threats, and governability and policy are extremely important when we are scaling the size of the composability and the interactions between agents and servers. So MCP gives us a scaffold to design boundaries, define and enforce those control points, so we can design applications that are really safer, more predictable, and easier to reason about. And I hopefully inspire you to think about that and apply that to your systems. Thank you.
Thank you so much, Maria. I've got to say, first talk doing a live demo, that is brave. And it worked really well. So I've never seen a live demo go off smoothly the first time. That was awesome. I don't have any questions coming yet. Is there anything that you would want to, I guess what I was going to ask is there anything you cut out for time? Like, is there something that you wanted, if you had a few more minutes, what would you want to tell us? Oh, you're muted.
If I had some more minutes, or if I could be more thorough, I'd probably go through the differences between developing the raw with the raw protocol and with the fast MCP, because I think there we have really a good space to realize what we might be missing if we are not paying attention in the quick and fast development with fast MCP.
Okay. And 'cause honestly, I'm a total novice at the MCP side of things. If someone were to do a little reading or kind of start somewhere, where do you start?
I would say that the documentation on MCP, that is in MCP.org from Anthropic, is the right spot. But I suggested also in this other slide some references, because there is where we can find a lot of what's going on when you are interacting in real world and scale settings. Yeah.
Awesome. All right. That is it. Thank you so
Thank
much.
you.
Thank you.